I bet you this is the most difficult chemical equation you can ever come across. The equation proves so stubborn to balance, but I'm going to balance it using what I call the LCM method. So stay tuned. Now, when you are given an equation to balance, the first thing you do is to rewrite the equation. So I rewrite the equation: ammonia reacting with oxygen to yield nitric oxide and water. Now, in the LCM method, we are going to list all the elements that participated in the reaction, then write their numbers at the left-hand side and at the right-hand side of the reaction. The first element there is nitrogen, and at the left, the nitrogen atom is one only one in ammonia. And at the right, it is also one in nitric oxide. So nitrogen is balanced for now. We go to the second element, hydrogen. Hydrogen is 3 in number in ammonia, and it is only 2 in water at the right. So the next element is oxygen. Oxygen is 2 in number at the left and also 2 at the right. So it seems that nitrogen and oxygen are balanced, but hydrogen is not balanced. Therefore, you have to start from the unbalanced element first. So in order to balance hydrogen, look at 3 and 2. Hydrogen is 3 at the left and 2 at the right. So these 3 and 2, look for the LCM. The LCM of 3 and 2 is 6, right? By 6, it means that 3 and 2 are the multiples, meaning that 3 times 2 is 6, and 2 times 3 is also 6. So apply this inside the equation. This 3 now will be multiplied by 2, written at the back, and this 2 will be multiplied by 3, written at the back. So we rewrite the equation, writing 2 at the back of ammonia to balance hydrogen to make it 6. So we have 2NH3 plus, you repeat what you see, oxygen to yield NO, plus, remember, 3 times 2, that is 3H2O. You go back to the table to implement the balancing. We said 3 times 2, right? So you write 3 times 2 and 2 times 3 here to make it 6. So hydrogen is balanced, as you can see. But in the process of balancing hydrogen, nitrogen became unbalanced. It was 1:1. Now it is 2:1. So this must reflect on the table. This 2 we have here means 2 times 1, right? So we write the times 2. Now in the equation, nitrogen is now 2 at the left and 1 at the right. LCM of these 2 and 1 is still 2. It means that 2 times 1 is 2 and 1 times 2 is 2. We are going to use 1 to multiply the 2 at the left and use the 2 to multiply 1 at the right. 2 times 1 at the left is still 2, but 1 times 2, we have to write 2 to multiply 1 at NO to balance nitrogen, and it must reflect on the table, 2 times 1. Now nitrogen is balanced, but in the process of balancing nitrogen, oxygen became unbalanced. 2 at the left, 2 plus 3 at the right, which is 5. We now have 2 oxygen at the left and 5 oxygen at the right. LCM of these 2 and 5 is 10. And 10 means 2 times 5 or 5 times 2. So 2 times 5 is 10, 5 times 2 is 10. Therefore, this 5 is going to be multiplied by 2 at the right, and this 2 is going to be multiplied by 5 at the left to get the LCM. So implementing it in the equation, 2 times 5, so 5 at the back of oxygen, and 2 at the back of the 2 compounds that contain oxygen at the right. So we make a bracket and write 2 outside. Remember, this 2 is not only affecting oxygen, it's also affecting nitrogen. And there are nitrogen atoms at the left. So these 2, we also multiply the nitrogen at the left times 2. And then we rewrite anything you write now is the balance equation. 2 times 2 is 4, right? So we have 4 ammonia molecules plus 5 oxygen molecules to yield 2 NO times 2. That is 4 NO, 4 nitric oxide molecules. And 3 times 2, 6 water molecules. If you check again, you will see that the equation is absolutely balanced. 4 nitrogen at the left, 4 at the right. 3 times 4, 12 hydrogen at the left, 6 times 2, 12 at the right. 5 times 2, 10 oxygen at the left, 4 times 1, 4, plus 6 times 1, 6, 4 plus 6, 10 oxygen at the right. If you found this video useful, comment, like, share, and tag your friends. And don't forget to subscribe to my YouTube channel.